one should receive a bit of training. One should spend a considerable amount of time using that technology, and then it becomes a commodity for you.
Hey, smart biotech scientists. We're in the middle of a discussion with Michael Sokolov. He's the co-founder and COO of DataHow, a spin-off company from ETH Zurich. And we are talking about why hybrid model is such a game changer and how you can leverage that right now in your workspace. Whether you are in a small company, whether you are working in a big company, if you haven't listened to the first part, go back and listen to the first part where we talk about the why, the potential of this technology. And now stay tuned for the second part where we're going to roll up our sleeves and going to get very tactical. And Michael is going to explain you how you can leverage hybrid modeling right now. Stay tuned. Welcome to the Smart Biotech Scientist podcast. I'm your host, David Brulman. Let's smarten up biotech. So before we move into a more practical, I'd say, or tactical part of our conversation, let's just zoom out and let's look at where you see this going, especially now with the AI that's just at a crazy speed. I mean, it's progressing machine learning tools. Like pretty much every day we have new tools at our disposal. So where do you see this going towards in 5 or 10 or 15 years down the road?
Well, I think here we need to understand that although AI is taking an omnipresent occupation everywhere, we are in pharma. It's a conservative industry and everything is taking longer. But as soon as this technology is used, it's embraced for a long time. You are also someone who knows multivariate analysis very well, and that's a technology which has been developed many decades ago and has prevailed as the status quo technology in the last 30 or 40 years in pharma. Now we're seeing hybrid modeling, machine learning is taking over, that become the new directions to go. So I hope that first of all, these technologies will become a new commodity, and then very likely these will establish themselves for a certain amount of decades, let's say, and thereafter these will grow with the additional machine learning power out there. It's very, very important to understand that unlike other industries where you have a daily access to new data, I mean, if we talk about social networks where on a daily basis terabytes of data are created and therefore give a huge basis for the data analysis community to find interesting information and trends. In pharma, we're still not in that domain where we're producing that amount of data, especially in pharma manufacturing. Therefore, we need to understand we live in a small data world. We have very complex practical questions which we need to answer. And therefore, the machine learning needs to be adapted and customized towards the specific nature of problems which we're facing. And the tools which will be able to consistently provide value in that uncertain environment will be the ones which prevail for a long time.
Yeah, that's great. Well said, Michael. Now, you mentioned the magic word practical. Let's get practical. Imagine that I am working in a smaller company, in a small startup, and I don't have all those fancy resources. So how can I, as a biotech scientist, get started and leverage these amazing hybrid modeling tools?
Assuming that you have a certain capacity of reactors available and you have a well-defined goal, which is very, very important to start with, being, for instance, improve your productivity, you would start with, let's say, an initial design of experiments where you would analyze possible degrees of freedom which you have in your process, being process parameters such as temperature, pH, the choice of the cell line, the choice of the reactor type or so. After running this initial, what we call calibration design, you would have a first understanding of what are possibly interesting triggers of the process. The model would learn about these, and thereafter it would suggest where to place the next experiments in order to get closer towards your goal. And like this, iteratively, fully respecting the capacity you have available, you would be driven by defining a process design which fulfills your process needs, which can be larger productivity, which can be certain quality attributes to be either low or high or in a specific range. So it's really an offline sparring partner which you can use in order to take better decisions about using your capacity and therefore converging faster towards your optimal design. Shall you, however, say, well, actually my processes are taking very long, and I'd like to actually optimize my process in real time. We have recently visited a very interesting lab which has been running plant-based cultures and with isolated plant cells with processes running for several months. Here the idea is to say that the hybrid model can be directly linked to the process as a digital twin. It learns as the process is running, and you can introduce perturbations during the run in order to see whether the process has a certain sensitivity to these changes or not. That's another very attractive possibility.
And how many reactors would you need to start? Is this just a few or several, or what is your recommendation?
So we have seen that there is very small companies with small capacity starting from either not even 10 shakers or just 4 or 8 bioreactors. That is completely sufficient because like this you have a parallel stack of systems which you can use to investigate different conditions and then fine-tune their combination to reach your optimal goal.
Wow, that's amazing. So you can start out with very little tools actually and leverage the technology. That's powerful. Let's talk about the digital twins. You mentioned that already. So how then do we go once we've started and we've generated the first few data sets? How do we develop this digital twin?
The idea of a digital twin is that only have a model which you trust in understanding your process and withdrawing relevant information of how to design it. But that sparring partner would be active in real time. That means you connect it in two directions. First of all, it fetches the data in real time from your IT environment or from the reactors directly. It processes them. It withdraws an important decision of how to operate the process. And instead of only displaying it on the screen, it feeds it back directly as a control loop into the system, allowing you to have less manual operations and a more adaptive nature, as in real time you're actually able to always link the running system towards the learning model and back towards an optimally controlled system.
Are there any pitfalls we should watch out for? Because obviously, if you're not so experienced, you might have the wrong data set or the experiment is not set up in the right way. Like, what are those pitfalls you've seen?
So I think on the pitfall side, first of all, it's very important that you start from a goal. You need to be clear, what do I actually want to achieve? Around the goal, you then start running experiments. And you start consistently, and not just once, consistently analyzing them with such a modeling. Like this, you are much more likely to withdraw relevant knowledge and accelerate your development timelines compared to just applying it to any data existing and without applying it to a goal you have defined upfront. These for me are the two most important things to start from. And very, very importantly, you should be also ambitious about what are your degrees of freedom and not saying, well, my temperature I know very well, I will not change it. I will also not change any other process parameters. I basically know exactly what to do. It's very nice to see that by going just slightly away from a set point where you might have thought it's ideal, you see important advantages which you can achieve by leveraging slight modifications around these so far known conditions. Therefore, you should be brave for analyzing change. But on the other hand, change is requiring quantification. So you should also be brave to admit that in your scope, certain changes do not have a strong effect and focus only on these where you see a very strong effect and explore these more in depth. And often the human cognitive ability is limited to rank these potential factors very clearly, to find their optimal combinations, and to do that with very few data. And this is where these models can help a lot.
Now, we've seen so far that hybrid modeling has a lot of potential. And even if you're working in a small company, you can leverage that and you can go very far and make your whole development process seamless. Now, another question, Michael, is where do you see the limitations of this powerful technology?
Well, limitations are around the fact that you need to manage your expectations. It's not a machine learning magic tool, which from today to tomorrow will improve your titers tenfold. It will not replace humans, but this tool allows you to handle your daily workload in a more efficient way. And if it's packaged well, it's also a tool which should be of interest for any user and not any data and only data scientists, to basically everyone who is producing data. So from my side, I'm really an advocate of that technology. Therefore, I would not say that there is clear restrictions which we need to take into account. But on the other hand, one should receive a bit of training. One should spend a considerable amount of time using that technology, and then it becomes a commodity for you. So with all the complexity which comes down to hybrid models and digital twins, I think as of now, software vendors like us are trying to package that in an as much as user-friendly ways. Therefore, the general bias that a modeling tool needs to be used by experienced modelers is completely not. Machine learning is now more and more becoming available to a very broad community, and therefore you should really address that as a general possibility you have. And maybe a last very important point here, as much as you're as a team addressing process development, you learn from each other. Someone is more expert on the side of, let's say, cell line selection, someone more on media or process design. Similarly, as a team, you need to build the digital infrastructure around the process. Someone might be more expert in databases, someone more in modeling, someone is producing the data in the lab but knows this data best compared to all of the others. And an ideal solution should allow all of these stakeholders to collaborate and to take decisions faster together.
You mentioned it before, Michael. You said that the pharmaceutical industry is conservative. So hybrid model is great, but this conversation wouldn't be 100% if we didn't talk about the regulatory environment, because everything is great if you develop it, but if you can't use it at large scale, I mean, there will be some limitations. So can you tell us a bit, what is the current regulatory perception and acceptance of this technology?
Yes, I fully agree. It's very important to involve the regulators in that perspective. And I think regulators have been great advocates to try and to use any forward-looking and promising technology. So there has been a very interesting publication, there was several follow-ups thereafter, of digital twins being required as a pillar towards Industry 4.0, towards more automated and adaptive process operation. That being said, these health authorities are not imposing which technology to use, but are advocating to try whatever new and promising technology is out there, especially in process development, where you are not obliged to document all of the procedures, but much more are obliged to document your process design in its robustness. A tool which has allowed you to define that faster and more accurately is, of course, of great help. Similarly, in manufacturing, when such tool is used purely for monitoring purposes, again, it's just a value-adding tool to your overall filing story. Only in the moment where you deploy the digital twin for active process control and manufacturing, of course, you require the complete GMP validation. But also here, similarly to other technologies which have made its path towards being validated as they have been becoming more and more popular and following the life cycle of a process from early stage development towards manufacturing, I'm very confident that in the filings soon to come, we will see more and more companies filing information centered around hybrid models being used, or even digital twins being used within their process development and scale-up activities.
Yeah, it's exciting to see where this will lead us, how it will change biomanufacturing. As we're wrapping up, Michael, what's the number one thing you want our listeners to take away from our discussion?
The number one thing is that if you are in bioprocessing, you should be using a digital technology consistently to analyze your data, whatever this technology is. This will allow you very strongly to accelerate the insights you're generating out of the data you're producing, and based on these insights to accelerate your process development or to reduce failures or human errors.
Thank you so much, Michael, for sharing this great insights. Do check hybrid modeling out. And Michael, where can people connect with you?
I would suggest that people can connect to us through our website, www.datahow.ch. We are also teaching numerous hybrid modeling courses, both digitally as well as in person in Zurich. So that's also an opportunity to get more about that technology. And if you're interested in a demo of our solution, you can really watch the videos online. So please feel free to contact us, but really look out for digital solutions that can be a big game changer in our industry in the future.
Thank you so much, Michael, for being on today. You will find all the links in the show notes below. Thanks again for sharing these insights, Michael, and thanks a lot.
Thank you, David, for having me.
All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.